So I'd like to begin the discussion of solutions by reminding ourselves how solutions fit into this matter tree, if you will. So remember, matter is the stuff that things are made of. So that's a really broad category. And then we can break matter into pure substances, which would be elements and compounds. And then where we're going to land in this chapter is in mixtures. Now, mixtures can be distinguished by some of their properties, including what they look like. So we can have homogeneous mixtures, and remind yourself that homogeneous visually, these are mixtures that look uniform. And then we could have heterogeneous mixtures. These have distinct regions, so you can see where the different things that are brought together in the mixture, you can see their areas. So for example, like if you had salt and pepper and then you mixed them together, when you looked at that mixture, you could see the pieces of salt and the pieces of pepper. That would be heterogeneous. You could see the different components. Now, solutions are homogeneous, and so this is where we are in this chapter. And so we'll be talking about homogeneous form of matter, solutions, specifically mixtures. And so recall, mixtures are going to have two or more components. So let's start in solutions by introducing what we call these components. So if you look at the picture below, we have the word solution, and this is just the definition of a solution. So it says it's a homogeneous mixture of one or more solutes dissolved in a solvent, which I find this definition problematic if you don't know what solutes and solvents are. So let's define those two things. So solutes right here, I'm going to grab a different color other than the black marker because I want to move it around. So solutes are going to be right here. And so the solute is what is being dissolved. So the solute is the substance that is dissolved. And what are we dissolving it into? We're dissolving it into a solvent. So if you look right below solute, there's the definition of the solvent. It says the dissolving agent that is usually the most abundant substance in the mixture. So there's always that word usually. So usually the solvent is the one that you have more of when you look at the different components. Now, I do have some specifics that sometimes help you with deciding what the solute and the solvent is, and that's down here beneath it. So notice that if you dissolve a solid or a gas and you dissolve them in a liquid, the solid or the gas is the solute and the liquid is the solvent. Now, on the next line, it says, well, what if we mix liquids and liquids? So if you mix two liquids, then we have to look at the quantity or how much you have of each. And so in this case, the smaller quantity is going to be the solute, and the greater quantity, or the one that you have more of, is going to be the solvent. So if you're mixing different states, so solids and gases, into liquids, the liquid is always the solvent. If you're mixing two liquids, then we'll look at the amount of the two liquids to see which is the solute and which is the solvent. In several slides, I will have a practice. So kind of just be thinking about those definitions and we'll practice before we end this short video. Now, true solutions do have some properties that we can look at. So number one, it says it's a homogeneous mixture of two or more components whose ratio can be varied. So in the previous page, we already identified a solution as a homogeneous mixture with two or more components. There's two or more because sometimes you can have more than one solute. Now, the thing here that we haven't mentioned is that the ratio or the concentration can be varied. So for example, just thinking in very basic terms, if you had a glass of iced tea and you wanted to sweeten it by adding sugar, you can add different amounts of sugar to make different concentrations of sugar. That's a property of a solution, that we can vary the amount of solute that we're adding. Number 2 said the dissolved solute is molecular or ionic in size. That's just saying basically when it dissolves, the particles are so small that we get transparent solution. So the particles are small enough that they don't scatter any light. So visually to us, they look transparent, or light can shine through, we can see through it. It's not cloudy or has particles in it, would be the contrast to transparent. Number 3, the solution can have color or it can be colorless. So remember in chemistry, when we're making observations, colorless would be like water as an example of a colorless liquid. And then the colored solution, we've seen several in lab. Like I know we've used blue solutions. I know there's been yellow solutions. So when a solution has when a liquid has a color like that, it can be a property of a solution. And I guess really what we're saying is the color doesn't matter for solutions. That will not exclude it from being defined as a solution. Then number 4 says the solute remains dissolved and does not settle out over time. So once we dissolve the solute into the solvent, a true solution, the solute will stay dissolved and not sink to the bottom of the container. Then number 5, the solute can be separated from the solvent by physical means. Evaporation is one that you could possibly use. So there's others, but evaporation is one we will experiment with in lab. So you will have a lab where you have a sodium chloride solution and you want to measure how much sodium chloride is present. So you will heat the solution, which will evaporate the water, leaving the sodium chloride behind. It's considered a physical method because the evaporated water did not change substances. It remains water, and the dissolved sodium chloride will remain sodium chloride. And so remember, physical changes, there's no change in the composition of the substance. Now, another thing, and you don't have to memorize anything on this. For the most part, in introductory chemistry, when we're talking about solutions, we're talking about a liquid solvent. So our solutions look like liquids. But I always like to point out that the definition of solution will allow for you to have a solvent in any of the states. And so like you can have air would be considered a solution. It's gases dissolved in gas or mixed in gas, I should say. You can have a water vapor in gas, so in air. So these are considered solutions. Then there's ones that we would be more familiar with, like carbonated beverages or gases dissolved in liquids, vinegar, acetic acid, and water. Salt water, you can see, and then really hard to imagine, but they consider something solid solutions that can be mixed uniformly. Now, solid solutions would not be considered transparent, but they are considered a uniform homogeneous mixture. So they give us 2 examples. So mercury, which is the metal that is a liquid, dissolves in silver. That's how they make the gray silver fillings. Or solids and solids, they have like sterling silver. I think of 14 karat gold, bronze, brass. All of these are solid, well, what they call solutions, but homogeneous mixtures. Now, solids, when you mix them, you actually have to heat them so they're molten, like a liquid solid, and mix it while they're molten. You can't mix something homogeneously when it's in a solid state. So again, you don't have to memorize this. I just want to give you some context for solutions so you're not thinking too narrow. But again, majority of what we will be looking at in our examples and in lab are have liquid solvents. So they will look like liquid. They'll be in a liquid state. Now, the last little part of this, I want you just to answer these two questions to see if you can identify the solute and the solvents in these examples. So you might want to pause the video, answer the questions, and then I'll be answering it. So if you're going to pause it now. All right, so let's answer the question. It says soda is a mixture of sugar, and there's other solutes, that's the among other things, in water. Which is the solute? So in this case, sugar, which is a solid, would be the solute, and water would be the solvent. So sugar is the solute, that's what's dissolved in the water. Water would be the solvent, that's the dissolving agent, and then the soda itself would be the solution. So that's how the definitions would fit this example. Then on the second one, a solution is prepared by adding 25 milliliters of ethyl alcohol to 75 milliliters of water. Which substance is the solvent? So these both in milliliters are both liquids. So when you're looking at two liquids, you have to look at the amounts. So the lesser amount would be the solute, and the greater amount would be the solvent. So we have ethyl alcohol. This is the solute. It's not the answer. This is asking what is the solvent. So letter B would be the answer. That would be the solvent. Now in both of these examples, I have water as the solvent, which water is a very common solvent, so it's not unusual. But be sure to read questions like this clearly. So for example, if the numbers were flipped and you had 25 milliliters of water to 75 milliliters of ethyl alcohol, then the ethyl alcohol would actually be the solvent, not the water. Okay, so that's our introduction into some of the vocabulary and properties of a solution. There's more to learn.